Hi everybody, this is Miss Nichols and this is the first flipped instruction video of the year. The topic is variables and units. Every video has an essential question. In this case, that is, what is a variable and how do I identify and label one? All numbers in the world can be categorized into either a constant or a variable category. Constants are numbers that have a set value that are the same for everybody that's using them, that aren't changing. Variables are numbers that actually depend on other things and might change over time. So for example, when I say dozen, everybody knows that I'm always talking about 12, whether I'm here or in Zanzibar or anywhere, which means that dozen is a constant. People and animals and objects are also constant because they don't depend on other things. They just are. Nouns, for example, they just are what they are. On the other hand, variables are values that actually can be changing. So if you look at the amount of money in your bank account, that's going to go up or down. It could even go negative if you borrow money from the bank. And other variables like your height changes over time, how fast objects go changes over time. These are all variables. Every number that you write or use in this class should be followed by what's called its unit. The unit is a word that gives meaning to the value that you've chosen. It tells me in the physical world how much are we actually talking about. It's also a really useful thing to help you identify what the variable is, because sometimes if you're just reading a word problem and you encounter a random number, you need to figure out which variable that number is referencing. For example, if you read the sentence, I'm going to give you 6, you hopefully are asking 6 what? That what is going to be the variable. Maybe I'm going to give you 6 candies. That would be great. So candies would be the variable, and it tells me how much and what I'm actually going to be giving you. Of course, I could have been referring to 6 bags of poop, which would be a little bit less desirable. So the unit is crucial. It changes everything about the number. The number for both of those examples was 6, but the object and the amount of that object are clarified by the unit. So one amazing thing about physics is that the entire universe can actually be described by a relatively limited number of actual variables. It turns out there's actually 6. There's only 6 things that can explain the behavior of every single thing around you. Some of those are ones you're familiar with, like, for example, time, distance. You probably have a sense of what that means, the mass of an object, and maybe you're also familiar with charge, which has to do with electricity. The last 2 fundamental variables we'll not be covering in this class. They have to do with tiny, tiny objects. It's called the color of a quark or the spin of electrons or other subatomic particles. But I just thought I'd introduce them here, even if we're not going to be using them in this particular class, because if you take more physics, you'll learn how important those 2 variables are as well. The first unit in this class is all about movement of objects, and we are going to be using 4 different variables during this unit. It's really important that you can identify these variables. If you see a number in a word problem, you could look at the units and figure out what it's talking about, and also that you have a sense of, relatively speaking, how big or small the values that you are going to be calculating are. The first variable is one I already mentioned, which is time, which is one of the fundamental variables. The second is distance, which is also a fundamental variable. And then the last 2 variables are made up of the fundamental variables. So velocity is a combination of time and distance. And you may already know what that means, but we'll go into more details in a minute. And the last movement variable is acceleration, which is also made up of time and distance in slightly different proportions. And again, you may know that word at least, but we're going to be talking a lot more specifically about what it means and how we use it in physics. So a good place to start is by being able to identify these 4 variables and tell what their symbol is, what letter we would use to represent this in an equation, the definition of it, and then some common units that we'll be using when we're using this variable in a calculation. The first variable is time. The symbol for time is a lowercase t, so if you don't want to write the entire word time, you can just write a lowercase t and everybody will know what you're talking about. The definition of time is how long something takes, which I'm sure you probably know. And the units of time, there's lots of different units of time, but the one that's highlighted there in yellow, seconds, is what's known as the SI unit, which means most scientists will use that unit most of the time. It's not the only one you can use, but it's probably the one you'll be seeing the majority of the time. The second variable for this class is distance. Again, the symbol is a very logical lowercase d, which you can write if you don't want to write that whole word. The definition of distance is how far apart 2 points are in space. And the units for distance are, there's a variety of units. In America, we use inches and miles pretty frequently, but the overall scientific community in the world much prefers meters and centimeters. So we're going to be using primarily meters in this class. In case you weren't sure how big a meter was, for me it's about the height of my leg, so that's not a bad way to approach it. Or you can just picture one of those meter sticks that you've probably seen in science classrooms, and that is 1 meter as well. The next variable is velocity, which will be represented by the symbol lowercase v in this class. And the definition that we're going to be using is how far an object moves in a certain amount of time. Velocity is very similar to speed, which you've probably used more frequently in your life. There's a small difference, which is that you can have a negative velocity, which means you're moving left or backwards, just a different direction, while speed is never negative. So that's the main difference between those two variables. The units for velocity we're going to be using combine the SI units that we've already learned. Like I said, this is not a fundamental variable. It's made up of other ones. And we're going to be using meters every second. When you see that word every in a unit, or if you hear the word per sometimes, that means divided by. So the way you should write that for short is m divided by s, or m over s. Typically. The last variable we're going to be using in this unit is acceleration, which can be represented by a lowercase a if you wanted not to write the entire word. The definition of acceleration is how much an object speeds up or slows down every second. This is a definition we'll work with throughout the entire year. I find that kids typically are challenged by the concept of acceleration because positive and negative acceleration don't mean what you think they mean, or the way that we typically use them in conversation. So in any case, just be prepared to wrestle with this concept a little bit as we get into it more. The units for acceleration are meters per second every second, because it describes how much an object's velocity changes every second. So if you look at that kind of for short over there, we've got the meters per second on the top of that fraction, and then the every means divided by second. Over the course of the year, we're going to be expecting you to demonstrate that you are proficient at a variety of different standards in this class. And one of those standards is mathematics. We're calling it SE2, which stands for Science and Engineering Proficiency number 2. And one little part of this mathematics standard is that we expect you to be able to identify the name, the symbol, the value, and the units for variables that you read in a word problem. So for example, if you read this little sentence, the hippo was 2.5 meters long, you should be able to, in the space below, write the name for that variable, which in this case would be the distance, the symbol that we use to represent that variable, or d, the value, which is 2.5, and then provide the units, which is meters, or m. If you read the next sentence, the onion rolled down a 20-meter hill in 40 seconds, that looks like two variables, but I'm actually expecting that if you read that all together in a sentence, you realize that we're actually talking about velocity, which is one of those variables made up of other variables, because velocity is how many meters an object covers every second. So the name would be velocity. The symbol would be a lowercase v. You need to do a little calculation to figure out what the value is, since it's the number of meters every second. If we go 20 meters in 40 seconds, we're actually covering a half of a meter every 1 second. So the value is 0.5, and the units would be meters every second. If you read it took 45 seconds to finish your homework, hopefully that's true for you guys sometimes. And hopefully you could quickly identify that we're talking about time, lowercase t, the value is 45, and the units are seconds. And then the last one says a race car goes from 0 to 100 meters every second in 2 seconds. So that's talking about an object's velocity changing in a certain amount of time, which should clue you in that we're talking about acceleration here, symbol A. Acceleration is how much my velocity changes every second. So if I go from 0 to 100 in 2 seconds, the value is 50 meters per second every second. At the end of every one of these slideshows, we'll ask you to take a minute to summarize. Specifically, you should be revisiting the essential question, which is what is a variable and how do I identify and label one? And writing, several sentences to a short paragraph about whatever crucial things you think were in this video. This should be in your own words, and should be, the place you start when you go back to review these things to make sure you understand them. Thanks for watching.